Complete the table for the proportional relationship represented by y equals 3 over 2x. What you are going to do is you're replacing the x value with the number provided. So it will look something like this. Recall that under every whole number there's an invisible 1. 3 times 5 is 15, and 2 times 1 is 2. We can change that into a mixed number. 2 fits into 15 7 times, because 2 times 7 is 14. Then to get to 15 from 14, we need one extra piece. So this is 7.5, or you can leave it as 15 over 2. If it comes out to a whole number, like 16 over 2, that should be changed to 8. But if it's a mixed number, you can leave it as an improper fraction if you prefer that. But make sure you line it up with the correct number. I plugged in a 5, and I got out a 7.5. Go ahead and plug in the remaining values into the x position and solve it for y. In this video, we have two, they're called graduated cylinders. We'll refer to this one as cylinder A and this as cylinder B. So which of the two cylinders filled faster? Cylinder B reached 100 milliliters before cylinder A did, so cylinder B fills at a faster rate. Based on the graph, how are you able to determine if the relationship between time and volume is proportional? We'll recall from earlier that in order to be proportional, it has to go through the origin and create a straight line. So both of these cylinders are proportional relationships between time and volume. It does ask us in part A, what is the unit rate of the proportional relationship represented by the red line, and how do you know? Well, with proportional relationships, if we're looking for a rate or a speed, it's going to be that quantity divided by time. Like in the case of miles per hour, hours is a form of time. Meters per second, that's a form of time. So here it's going to be milliliters per second. So I see that there's a point here at 2 and 40. So I'm going to take the volume, which is the quantity, and divide it by the time, which is 2. So that is 20 milliliters per second. And in the spot where it says, how do you know? Well, the point 120 is on the red line. We used to talk about the point 1, k, where k was that constant of proportionality. It's been a while since we talked about this. I think that was back in 7th grade. Now let's do the same thing for the blue line. Well, the blue line has 40 and 4. 40 divided by 4 would be 10 milliliters per second. And if we look, the point 1, 10 is on the line. So we know that the constant of proportionality is 10, per second, and this one is 20 per second for the red line. The data in the tables show the relationship between the time in seconds and the volume of water in milliliters for each graduated cylinder. Use the table to determine the rate at which each graduated cylinder fills with water. Cylinder A fills at 10 milliliters per second, and cylinder B fills at 20 milliliters per second. Then in part B, it says which graduated cylinder fills with water at a faster rate, which is cylinder B. Because in 1 second, it already has an additional 10 milliliters more than cylinder A. For cylinders A and B, identify which equation relates the time x in seconds to the volume of water y in the graduated cylinder in milliliters. The one that filled at 20 milliliters per second was cylinder B, and the one that filled at 10 milliliters per second was cylinder A. The equation y equals 123x represents the time x in hours needed to produce the number of toys y at a toy store A. The graph shows the proportional relationship between the time and the number of toys produced at store B. What are the unit rates for the relationships represented by the equation and the graph? Explain. So for store A, that unit rate is 123 toys per hour. It's the constant of proportionality in the equation. We worked with equations in this form, y equals kx, a lot in 7th grade, and the k represented that unit rate. Here in store B, this is 100, 120, 140, 160, 180, 200. So it's at 120. Toys per hour, as it's in the form. One comma k, we have this point 1 comma 120. Which company produces toys at a greater rate? Company A, or store A, produces toys at a greater rate because 123 toys per hour is greater than 120 toys per hour. The equation y equals 6x represents the distance y in miles Mrs. Banks drives in x minutes. The table represents the relationship between the time in minutes and the distance in miles Miss Hawson drives. Assume both women drive at constant speeds. What are the unit rates for the relationships represented by the equation and the table? And explain. So in the form y equals kx, again k is the unit rate. So for the equation 5/6, which is Mrs. Banks, and that is miles per minute, 5/6 of a mile per minute for Mrs. Banks. In a table, the unit rate can be found by dividing y by x. So for, this is Miss Hawson, the y divided by the x, she goes 2/3 of a mile per minute. B says who drives at a greater rate of speed? So we have 5/6 for Mrs. Banks and 2/3 for Miss Hawson. Well, since this one's out of 6, we might want to make this one out of 6. 3 times 2 is 6, and 2 times 2 is 4. So 5/6 is greater than 2/3, because 5/6 is bigger than 4/6. And 5/6 was the rate for Mrs. Banks. She goes farther in a minute than Miss Hawson. The graph represents the relationship between time in minutes and volume of water that flows from a faucet A in gallons. The table represents the relationship between time in minutes and volume of water that flows from faucet B in gallons. Assume the water flows from each faucet at constant rates. What are the unit rates for the relationships represented by the graph and the table? Explain. Again, to find k, we do the y value divided by the x value. So I can do that for both of them. So for faucet A, I'll just write A, we have the y value is 8/7, and the corresponding x value is a 2. We can change that to multiplication and flip that fraction over, and we get 8/14, which can be reduced to 4/7. For faucet B, the y value divided by the x value, 5 divided by 9 is 5/9. So that's 5/9 of a gallon per minute. And this one is 4/7 of a gallon per minute. And then it says which one is a greater rate? Well, 4/7, if we were to do that as a decimal, is about 0.571, and 5/9 as a decimal is about 0.55, and it's 5 repeating, but we'll round that third one up to a 6. So, which is a greater rate? Well, 5/7 is bigger than 5/5. So we're going to say A is a greater rate because this is greater than this decimal. It gets more water in 1 minute than Faucet B. Make sure that your workbook is filled in for lesson 15. If you have any notes that you need to write down again from all those things we talked about back in 7th grade, and then check back for lesson 16.